Okay, we're going to be talking about reliable methods for finding truth. Most people would agree that they want to have beliefs that are true and they don't want to believe things that are false. But it is very important that you use a reliable method when determining what is true and what is false. Before we get into the method for finding truth, let's go over some concepts in mathematics that will ensure that the concept is clear. In mathematics, functions are defined by the term f of x and contain some variable x and output the result f of x. For example, f of x equals x plus 2 is a function. Using the example of f of x equals x plus 2, we can visualize what the function does by drawing the input and output sets. So here we have an input set on the left and an output set on the right, and we will denote the relationship between the input and the output with an arrow that is, in this case, f of x equals x plus 2. So if we put some numbers in our input and output sets, we can see that when we apply the numbers we get from the input set, we go to the output set. When we plug in 2, we get 2 plus 2 equals 4, and so on. And so we can draw these arrows so that 2 goes to 4, 1 goes to 3, and so on, with this function f of x equals x plus 2. The term mapping is used when we're trying to describe what the function is doing. We say that f of x maps the input 2 to the output 4. It just simply says we take the input and we map it, or we put an arrow going to somewhere in the output. But it is important to remember that the relationship between the input and the output is the function itself. We can also subcategorize the input and the output sets to be a little bit more specific and to show properties. In the case of numbers, we can show positive numbers, neutral numbers, and negative numbers, like so. This allows us to be able to show more structure in the sets and maybe deduce more conclusions based on them. But how does this relate back to reliable methods for finding truth? Well, if you think of the input to a method to be similar to the input of a function in mathematics, only instead of inputting numbers, the method will input a claim and output true, false, or unknown. So in this case, we'll have an input set on the left and an output set on the right again. Only instead of numbers on the input, we're going to have claim A, claim B, claim C, and so on. And on the right, instead of mapping to numbers, we're going to be mapping to true, false, or unknown. And we'll be denoting that with arrows again, and with the method, whatever that method might be. So how do we determine reliable methods from unreliable methods? Well, a claim can only be true or false. A method can, however, output unknown, which just means that there isn't enough information when applying this method to be able to come to a solid true or false response. With this in mind, we can spot unreliable methods by mapping inputs to outputs in a contradictory way, and I'm going to list 2 examples in just a moment. But any example that you can come up with that is contradictory is going to make that method unreliable. For example, if we have a claim, as shown on the input on the left here, if that claim can be mapped to both true and false, the method that did that mapping is unreliable. This is because you cannot both be true and false simultaneously. Only one of those things can be true. Another example would be that a claim that we know to be true is somehow mapped to false with this method. Then that method also would be unreliable. And any other contradictory way of mapping would also make a method that does that contradiction unreliable. As it turns out, the only reliable method we have developed is the scientific method. The scientific method is that we, 1, develop a hypothesis, 2, we determine the consequences of what that hypothesis implies, and 3, we perform a test or an experiment. If the hypothesis passes the test, then we move on to the next step. If it fails the test, then the hypothesis is wrong, and we discard that and we place that into the false. We map that hypothesis to false. If the hypothesis did pass the test, however, we then try to devise another test to test the hypothesis again, and we continue to do this over and over and over. The entire method is that we're trying to disprove the hypothesis, and over time, when the hypothesis continues to pass every test that we can come up with, the hypothesis gains credibility as to be likely true. We never claim anything is absolutely true, But if a hypothesis is set past 1,000,000 tests and we can't hardly think of any more tests to give it, it's pretty likely that that hypothesis is true. Anyway, I hope this presentation over reliable methods and unreliable methods and why it's important to use reliable methods for finding truth helped you out to understand it. Anyway, take